Integrated 2, Chapter 5, Part 1, Day 3. A couple of things I wanted to point out. First of all, this A thing, it's shown up. I've talked about it briefly. We're really going to sort of hammer the A part today if you've been wondering, what we've been waiting for so long on that. So the idea would be really we should have a really good understanding of both of these things. That's not the entirety of the chapter, but we really should have made sense for the most part of what's going on with quadratics in standard form and factored form by the end of the day. I did want to point out, like, why do I keep using this form as a guide? Just because I want you to see it. If we do it the same every time, it shouldn't really throw us any curveballs. It shouldn't be a big deal at all. So we're going to start this one the same way we always do. So y equals negative x squared minus 2x plus 15. So this one is a lot different than what we're used to. We haven't really seen one with a negative a yet. And I know I showed in an earlier video, if it has a negative a, what happens. But we haven't really dealt with this before. And you may recall, so two things that we talked about in a previous video that I wouldn't necessarily expect you to remember, but I did mention briefly. One that I mentioned was that if we have a negative and we're going to factor out, my suggestion to you would be to factor out the negative. You can see 1, 2, and 15. No number is going to factor out of there, but if I factor out a negative, that's going to leave me a positive a inside the parenthesis, which I'm a big fan of. I would always tell you to do that. So you might remember that from a previous video, you might not. If you don't, that's fine. But you can see a negative times x squared is negative x squared, a negative times 2x is negative 2x, and a negative times negative 15 is positive 15. So there we go. But again, to me, this is the crucial part right here. We want to make sure that this right here is positive. Again, we don't want to forget about this negative 1. This negative 1 is going to end up showing up somewhere down here. But we do want to work with a positive a here. You don't have to. It is possible to do it the other way. But I just think it makes it more complicated. So a times c is negative 15, b is 2, I have 1x on the side. Again, hopefully we see 5 and negative 3 is what's going to get that. 5 times negative 3 is negative 15, 5 minus 3 is 2. So when I rewrite this equation, don't forget that negative 1. I'm going to have x plus 5 and x minus 3. So what are my x-intercepts going to be? Well, x plus 5 equals 0, so x is going to equal negative 5. So I have an x-intercept at negative 5, 0, and x minus 3 equals 0, so x equals 3. I have one at 3, 0. So here we go. These are going to be our x-intercepts. At this point, my y-intercept is just going to be 0, 15. Right? So getting some important pieces of the puzzle here. My axis of symmetry is just going to be negative b over 2a. And again, we go back to the beginning. So negative b is a negative, negative 2. 2 times a is negative 1. We made it positive for this step only. Again, we go back to the original. So a negative, negative 2 is 2. 2 times negative 1 is negative 2, so we're going to get negative 1. So this is going to be our axis of symmetry. And then we can just go back to the original equation. Y equals negative 1 squared minus 2 times negative 1 plus 15. I know I can do this in the calculator, and I've done it in the calculator more often than not, but I do want to do this one by hand just to show you order of operations. A lot of kids get real screwed up right here. Remember, exponents happens first, so this is going to be like negative 1 times negative 1 is positive 1. But we haven't dealt with this negative yet. So I hope you guys see what happened there. Again, I didn't deal with this negative. I just dealt with negative 1 times negative 1 is positive 1. Now I will introduce this negative. A negative times a negative is positive, plus 15, so I'm going to get 16. So my vertex is going to be negative 1, positive 16. Again, if I want to do a quick little ugly graph here, negative 5, 0, positive 3, 0. I have one at negative 15. So what's going on here? Why is my y-intercept way up here? How can I, like, is it going to look like that? That doesn't seem like it makes sense. My vertex is at -116. So hopefully we kind of get what's going on here. This thing, and you might remember from an earlier video, this thing's going to actually open down. So let's pause. Let me put this in Desmos and let's take a look at this. We have our vertex at -116 like we expected. Our y-intercept is 0.15. X-intercept's at -5, -3. So let's go ahead and take a look here at what I had mentioned at the beginning of this video, which is that we're really going to begin to explore this A. The A is going to tell us two things: if it opens up and if it's flat or not. That's essentially the two things it's going to tell us. So again, I think we had already talked about this. If this is positive A, this parabola is going to open up. If it's a negative, it's going to open down. The next thing I want to do is I want to get the absolute value of the A. So if the absolute value of my A is greater than 1, it's going to be steep. If the absolute value of my A is equal to 1, it's going to be normal. But if the absolute value of my A is less than 1, it's going to be flat. And again, remember, absolute values are always positive. So if the absolute value of my A is greater than 1, it's going to be steep. If my absolute value of my A is 1, it's going to be normal. If my absolute value of my A is less than 1, it's going to be flat. So let's take a look at what I'm talking about over here. Let me kind of, I don't know, let me see if one of these is a better example. Okay, so again, if I make this thing negative, it's going to open down, which should not surprise us. That's pretty easy. The first part is pretty easy, right? If it's negative, it opens down. If it's positive, it opens up. The second part is the steepness, right? So if I make this thing 22, my absolute value is 22. You can see how steep that is, right? If I make it 222, you can barely even tell it's a parabola. It starts to look more like a line, right? Because it's so steep. However, what if I do something like make it 1/2? Now it is, my absolute value is less than 1, and you can see it gets flatter, right? So we can actually compare some of these different parabolas. So let's do something like, let's just make it easy. Let's do an easy comparison. Here's y equals x squared. Let's do y equals 12x squared. Actually, and that was doing what I wanted it to. And then let's do y equals 1/2 x squared. So you can see what's going on here, right? You can see that the higher I make the absolute value, the steeper it gets. Whereas the lower I make the absolute value, the flatter it gets. Let me change something. I can't remember. Okay, there we go. I'm going to add a slider for A. So this is what I wanted to do here. So watch what happens here as I change the slider. As I go steep, you can see it gets, as I go high on A, it gets steep. It just let me put a slider in here. And as I go closer to 1, it's going to get flatter and flatter, right? And once, this would be considered normal. Once I get below 1, you can see it gets really flat, right? Then when I go to negative, you can see, again, the absolute value, the absolute value is still less than 1, so it's flat. But as it gets closer to the absolute value again of 1, it gets to normal. And then if the absolute value gets above 1, it will get steep again. So hopefully that makes sense. When we look right here, we want to recognize that it doesn't matter which form it's in. If it's in standard form or factored form, when we look at the A, we can notice if it opens up or down, and we can notice if it's steep or flat by looking, or normal, by looking at the absolute value of the A term. Alright, so let's go ahead and set up the next problem. Time to pause and do a check to see if you can do this for yourself. So I will take a second or two. Hopefully you paused it and we'll see if we agree. So again, the first thing I'm going to do is factor out that -1. If I could factor out a bigger number, I'd factor out a bigger number, but I'm at least going to factor out that -1 so that it ends up being an A that's positive when I do the diamond. So A times C, B, it looks like a 4 and a -2 are going to work here. By the way, hopefully now, again, I told you in chapter 4 it didn't matter if you forgot this -1. Hopefully you can see how important it is to remember now. Remember, I did tell you it would become important later. So here, it will be the difference between a parabola that opens down and a parabola that opens up if you screw that up. All right, so I'm going to get -4, 0, and 2, 0. If you don't believe me, you can do that. I haven't shown the shortcut here, but I'm sure a lot of you have already figured out the shortcut by now. Here, I'm going to get 0, 8. Here, I'm going to get -b over 2a, so I'm going to get -2 over 2 times -1, which is also -2, so I get 1. That doesn't sound right. -b over 2, -b over 2a. Yeah, I'm getting a 1. I should be getting a -1. Let me see what's wrong. Let me pause. Up at the top, a times c is -8, b is -2. This should have been a -4 and a +2. Ugh, good night. That is frustrating. All right. I think I'm too far into this video to start over now, so I'll just put something in the comment section like I'm so used to doing that I screwed up. Frustrating. Hopefully you caught the error at least, and I'm wondering what the problem was. All right, so I'm going to get x plus 4 and x minus 2. So I will get -4, 0, and +2, 0, I think. Now I'm really wondering if I didn't screw this up beyond recognition. Here I'm going to get 0, 8. I'm going to have faith in myself and just see what happens. So -b over 2a, I should get a -2 over 2 times -1 is -2. I should get 1 again, and that is wrong. Oh my goodness. I've given up on this video by now, but instead I'm just going to put a comment that says to skip these seconds. So a times c is -8, b is -2. I have 1x on top. If I go 4 and 2, it will work if this is negative. So -4 times 2 is -8, -4 plus 2 is -2. So let's see what happens now. So y equals -1 times x minus 4 times x plus 2. So this would be 4, 0. This would be -2, 0. This would be 0, 8. You'd think I'd have checked this in Desmos by now just to come back and make sure I didn't screw this up, but pride goeth before a fall. All right, so -b is -2. 2a is also -2. And I get 1, which I expect to get. Yay! Good night. Sorry for the troubles. Again, I'll just say to skip it. Oh no, but if I put this in Edpuzzle, you won't be able to skip it. That sucks for you. All right, I apologize. Honestly, I feel bad about that. By the way, you could plug the axis into this equation and you would get the same thing as if you plug it into this equation. So let's plug it into here just to show you what I mean. It's a little bit easier sometimes to plug it into here. So if I plug 1 in for x there and 1 in for x there, I'm going to get -1 times -3 times 2. So -1 times -3 is 3 times 2 is 6. So I will get 1/6 as my axis of symmetry. I'm sorry, as my vertex. And again, if I plugged it in up here, you can see I get -1 plus 2 plus 8, and I get 9. Why is my life so bad? 6 here, -1 negative 10. I don't know. I'm giving up now. My own handwriting. This is a 2. So 1 plus 2 is a 3. So I would have gotten 9. Oh my gosh, what a disaster this video has been, at least this part of it. The problem is, I really don't want to redo the beginning of it. Alright, so if we go back over here, you can see I finally did give up and check to see what my problem was, and I did get this. Again, I will make a comment, and you know what, if I remember, I might not actually make you guys watch this one in Edpuzzle. I might just let you guys skip ahead, because this really has been bad. But again, I have no shame, so not bad enough. All right, let me pause it and set up the next problem. So let's see if I screw this up too. So in this one, I can obviously take a 2 out. It looks like 2 will be the biggest thing. 4 doesn't go in and 6 doesn't go into these. So again, I'm going to take a negative 2 out, so I end up with a positive a right here. This would be a minus 10x. A negative times a negative is positive. And this would be a negative 8. So a negative times a positive is negative, a negative times a negative is positive, a negative times a negative is positive. I'm going to try and be extra careful since I screwed up the last one so bad. A times C is negative 24. B is going to be negative 10. On the sides, I will put 3x. I will now try and pick these numbers correctly, unlike last video. So it looks like 2 and 12 is going to be what I'm going to use here. And it looks like the 12 needs to be negative. 2 times negative 12 is negative 24. 2 minus 12 is negative 10. If I can simplify, I cannot simplify here, but here I can simplify. 3 is going to go into 3 once, and 3 is going to go into negative 12 negative 4 times. So I will use these, and I will not forget about this. So I will get y equals negative 2, 3x plus 2, x minus 4. Here, I'm going to get 3x plus 2 equals 0. So I'm going to get 3x equals minus 2. So x equals negative 2/3. So I'm going to have negative 2/3 0 as an x-intercept. And here, it's obviously just going to be 4. So 4, 0. These are my x-intercepts. I'll go up here for my y-intercept. It's just going to be 0, 16. Always the easiest point to pick. My axis of symmetry will be negative b over 2a. So negative b will be negative 20 over 2a would be negative 12. So if I simplify that, it will be positive, positive 10, 6, so positive 5/3. 4 goes in. So that's like 1 2/3, or I can use 5/3. It's up to you which you would rather use. I might rather use the fraction, especially if I was going to hand plug this in. But long story short, I have screwed up enough in this video, so I'm not going to attempt fate. I will plug this into my calculator. And let's see what I get out. So I will say negative 6, 1 point, again, I'll just put a few of these, plus 20 times 1.6. Order of operations, super important. Make sure you don't mess it up. And I'm going to get 32.67. So 32.67. So this will be my vertex. So not an easy problem at all. Let's go ahead and put this in Desmos and see if we got it right. Not right. Again, I apologize for all the errors. I will definitely go back through and make some comments, and hopefully I'll remember not to put this one if we're not back from coronavirus. God, I hope we are. It'll be like Christmas time, I think, by the time we watch this video, roughly. So here's hoping that you never actually watch this video, because we're back in class. Have a good one.